Good morning, everyone. In this last lecture, we have seen the testing of hypothesis for single mean using t-test. For t-test, there are for small sample. We are using t-test. This is for based on mean, based on mean, meaning average. Another one is based on proportion. So whenever small sample comes, we use mean, and whenever large sample comes, we use proportion. So based on proportion, we check. We have two things. One is single sample, another one is two sample. For proportion also, we have use one sample test, another one is two sample test. So here two tests. Last class we have dealt with single mean. Single mean means there is only one sample. Here we are going to see uh, difference of testing of hypothesis for using t-test. So here test statistic calculated value is being calculated using x1 bar minus x2 bar divided by s into 1 by n1 square root of 1 by n plus 1 by n2. So what is x1? x1 is mean. X bar is actually mean. X1 bar is mean of first sample. X2 bar is mean of second sample. And then S is standard deviation. Standard deviation. But here standard deviation would not be given straight away. The sample once standard deviation S1 would be given, and then standard deviation of sample 2 S2 will be given. From this S1 and S2 we have to calculate the value. For this we have to use this formula. This is equal to square root of n1 S1 square plus n2 S2 square divided by n1 plus n2 minus 2. Suppose x1 and x2, s1 and s2 are not given straight away, and the data is given. From this we have to calculate x1 bar, x2 bar, s1 and s2, so and so. We could find x1 bar and x2 bar using the formula based on whether it is raw data frequency distribution. If it is raw data, we use x1 bar is equal to summation of x by x1 by n1. X2 bar will be calculated using summation of x2 bar divided x2 divided by n2. From this, we can calculate yes, summation of x1 bar, x1 minus x1 bar whole square plus summation of x1 plus x2, x1 minus x2 bar whole square divided by n1 plus n2 minus 2. So now here either two way, if value is x1 bar mean and standard deviation are straight away given, we could use this formula to calculate standard deviation. If the data alone is given and x1 bar mean and standard deviation are not given, we need to calculate using this relation. So remaining things are the same, but what to do? We have to define hypothesis, null hypothesis, and alternative hypothesis, level of significance, and then calculated value, tabulated value, comparing calculated value with tabulated value. Calculated value is lesser, the tabulated value we accept the null hypothesis. If calculated value is greater than tabulated value, we reject the null hypothesis and accept the alternative hypothesis. Based on this, we can write the result. So here, as far as this problem, let us read it out. The average number of particles produced by two machines per day are 200 and 250 with standard deviation 20 and 25 respectively on the basis of record of 25 days of production. So they want to calculate the machine's efficiency. So how here can you regard both the machines are equally efficient at 1% level of significance? It is the requirement to check the efficiency of your machine. You have to check maybe for whole year or for a certain amount of period we are going to check. We need to check the efficiency of machine. For this, we are collecting some samples. Maybe this particular month for 25 days, or from this month 2 days, from the next month 3 days, from the next month 3 days, so on so for 25 days we are collecting samples. This is they are doing. So based on 25 days of sample, the average number of particles produced by machine 1 is 200 and machine 2 is 250 with standard deviation is 120 and with standard deviation 25. So based on the sample collected, we have to check whether both the machines are equally efficient and what was the level of significance for this. So let me write all the data given from machine 1 and the machine 2. Machine 2. So in machine 1, x1 bar. What is the average mean? Mean is given 200. So for machine 2, 250. And then standard deviation S1. Yes, this is x2 bar. Okay. Here S1. S1 is given standard deviation of machine 1 because it is respectively 20 and for machine 2 25 is to 20. And then sample size also given. What's the sample size? For how many days they are verifying it? For 25 days, both the machines. So sample size n is equal to 25 for machine 1 also 25, machine 2 also 25. These are the values data given. So based on this, we have to set the null hypothesis. Null hypothesis is, what is null hypothesis? What is the claim of the claimant? So what's the claim of the claimant? Can you regard both the machines are equally efficient? So we have to consider whenever we say null hypothesis, the hypothesis should be there is no difference. When comparison comes, there is no difference. When we take the mode of the sample to the population, there is no the sample is taken from the population. This is what the null hypothesis we should have. So here null hypothesis H naught is both the machines are equally efficient. This means in notation we can write it as H naught is H naught as x1 bar is equal to x2 bar or H naught as mu1, where from the sample taken from it's a population mean, this is mean sample. So its population is mu2. This also we can have as notation. And then alternative hypothesis. Alternative hypothesis is just entirely opposite of null hypothesis. H1 is equal to V1 is not equal to V2. This means both the machines are not equally efficient. Now we have to go for null hypothesis. Level of significance. Level of significance is given as 1%. For small sample, if no information about the level of significance is given in the problem, we have to consider it as 5%. But large sample, it is not the case. So now we go for calculated value. Calculated value is t is equal to x1 bar minus x2 bar divided by is into square root of 1 by n1 plus 1 by n2. So all the values, x1 bar we have, x2 bar we have, n1 we have, n2 we have, but s is not available. So to find this, we have to use this relation. This is equal to square root of n1 s1 square plus n2 s2 square by n1 plus n2 minus 2. So we know n1 is what? 25 into s1 square. S1 is what? S1 is what? 20 into 20 square plus 25 into is 25 again into s2 is 25 square whole divided by n1 25 plus into 25 minus 2. When we simplify this, we will get 23.105. I will let you know how to simplify later. So we could calculate using the values here. So calculated value formula is t is equal to x1 bar 200 minus x2 bar. X2 bar is what? 250 divided by s is just we calculate 23.05 square root of 1 by n1 25 plus 1 by n by 25. 1 by 25. So here when you simplify, you will get negative value minus 7.6509. So here actually when negative value comes, we should not compare this with the negative value with the tabulated value. We need to make it positive. So that's why we consider modulus value of the test statistic. So modulus T is equal to negative 7.6509 is equal to 7.6509. And then we have calculated value, and then we need to find tabulated value. So in order to find tabulated value for small samples, we need three things. One is what kind of test it is, either one line one type test or two type test. Another one is the level of significance. Another one is degrees of freedom. These three things we require to find tabulated value for small samples. So here, what is the level of significance? Level of significance is given as 1% in the problem. So this is 0.01 or 1% level of significance. Actually, 1% level of significance means 99% level of confidence. That much it is reliable. And the degrees of freedom from relation to find degrees of freedom is n1 plus n2 minus 2. So n1 is 25 plus 25 minus 2 is equal to 48. So tabulated value to check here it would be given. So here it will be degrees of freedom will be in the T table will be given to you separately. Degrees of freedom will be in the left side in top. Level of significance will be available for 1%, 2%, 5%, and 10%. Or this would be given as 0.01, 0.02, 0.05, 0.01, 0. So in some tables there would be separately for two type tests and one type test would be given. So this is one type test. For two type tests, the level of significance will be given accurately. So now degrees of freedom will be 1, 2, 3, and so on till some value. So 100 and so on. Here, what to do? We have to check the degrees of freedom to check the tabulated value. What is the degrees of freedom value against a particular degree level of significance? Suppose here it is 48 is given as degrees of freedom against 48 for 1% level of significance. What is the value given here? This is the required tabulated value. So if suppose if it is 36 and 5%, we have to check the value here. From the table we have to calculate. So I will show you the table later. Okay. So we have found the value 2.576 as tabulated value. We need to compare both the values. So calculated value is 7.5659, tabulated value is 2.376. When we compare this is what T modulus T. This is what T alpha. This is what calculated value. Greater than this is tabulated value. When calculated value is greater than tabulated value, what we do? We reject the null hypothesis and accept the alternative hypothesis. Based on this, we could write the result. What's the result? When we what's the result based on an alternative hypothesis? We accepted both conditions are not equally efficient. This is what we conclude the claim of the claimant. Okay. Before finishing this video, I just want to show you how to calculate this in the calculator straight away. So here, this part I am taking. Here 25. So square root comes. Whenever square root comes, make a bracket. Whenever division comes, make another bracket. Okay. So here, this is numerator. This is denominator. Whenever numerator and denominator comes, make this bracket. So what are all given in the numerator? Write 25 and then into 20 squared and then plus and then 25 into 25 squared. So here numerator ends. Stop with that. And then here what is this? Division symbol comes. use division symbol. Again, denominator starts. So make a bracket here. What is written in the denominator? Let us it is 25 plus 25 minus 2. So here numerator ends, denominator ends, close it. So before square root we start an open bracket, here close an open bracket, a close bracket. So if you count the brackets left hand side 1, 2, 3, there should be equal number of closing brackets corresponding to its opening brackets. So 1, 2, 3. So, and then use equal, press equal, you will get the value 23.1059. Now, here also there is another calculation. Here there is numerator, there is denominator and division symbol. So here open a bracket, 200 minus 250, close the bracket, division symbol. So use division symbol. So whenever denominator comes, open a bracket, and then here 23.1053. So before after this value, there is square root comes, use multiplication symbol, and then open square this one, and then here after square root there is two divisions. So make a bracket to this. So this is separate one. So make another bracket 1 divide 25 and then plus. For this make another bracket 1 divided by 25. Close this. Here what ends? Denominator ends. So close it. So this is the bracket corresponding to this. There is another bracket should be corresponding to this opening denominator bracket, and put equal, you will get the value this one. What is that? 7 point this one. Okay, this is how you have to calculate it. Okay, I'll show you the table another day how to calculate the table value. Thank you. With that I stop. I stop the video, and from next video we'll discuss proportion test for one sample and proportion test for two samples. Thank you.